Find the general solution. Sin x over 1 plus y times the y dx equals to cos x. Okay, so let's take it one after the other. We have sin x over 1 plus y multiplied by the y dx equals to cos x. Now, I will bring this part that has y with, I will bring it beside this dy. Why I will bring this part that has x, this, and this to the other side. I'll bring the one that has y and dy in one side, and this part that has x and this and the x in one side to join this. So how will I go on with these steps? Okay, firstly, if I use this one to multiply this, it will give me what? Sine x dy all over into bracket 1 plus y dx, right? This is what it will give me, equals to what? Cos x. Okay, now I will now cross multiply. I will cross multiply. So if I cross multiply, I will use this one to multiply this. I will now use this to multiply this. So if I use this one to multiply this, it will still give me this. So which will be sine x dy. If you see, this is x beside the y. No, I want y to be here, not sine, not x. So let's continue. So this multiplied by this, it will give me this, equals to cos x multiplied by this, it will give me what? Cos x into bracket y. Or let me write this first. Let me write 1 plus y, close the brackets. I know that there's dx here, but let me multiply this with it before I write the dx. Cos x dx, right? Now you can see part of y here and x here. What will I do? I will bring this y here. I will now bring x here. So for me to do that, I will divide both sides. For me to bring this x to this part, I will divide both sides by what? Sine x. First, I will divide both sides by sine x. I will divide both sides here by sine x. So this will cancel this. I will be left with dy equals to 1 plus y cos x dx all over sine x, right? Okay. So for me to bring, don't worry, don't feel concerned with the way I draw the line here. It's still the same as this. So for me to bring this 1 plus the y to the other side, I will divide both sides by what? 1 plus the y here. So I will divide both sides by 1 plus y here, 1 plus y. So this will cancel this. Okay. So at the left hand side, I have what? Dy over bracket 1 plus y. And at the right here, we have cos x dx over sine x. Cos x dx over what? Over sine x. Okay. So I can further rewrite this like this. It's the same thing as 1 over 1 plus y dy, right? If I use this dy to multiply this one, it will still give me this. So here we have cos x over sin x dx, right? So what is the next step to do? Is to take the integration, that is of both sides. Take the integral of both sides. So I will take the integral of both sides. I will take the integral of both sides. Integral of both sides. Okay. Let me write the symbol very well. Take the integral of both sides. Now, if I take the integral of both sides, if I integrate this with respect to the y here, what will it give me? Now, I've prepared video on this, on integration using substitution method. You can watch it. So you notice that whenever you differentiate this denominator, it will give you this numerator, right? You know, whenever you are differentiating this now, this one is a constant, so it will change to 0. But whenever you differentiate just ordinary y, you know, if you differentiate y, it's just like y raised to the power of 1. And if you use general method, you use the 1 to multiply it, which will become 1 times. Then you subtract 1, it will become y raised to the power of 0. And y raised to the power of 0 will give me what? 1. That is 1 times 1 will still give me 1. So this will give me 1. So that is, if I differentiate this denominator, it will give me the numerator, which is 1, right? If you have noticed that the differentiation of this denominator is equals to the numerator, then you take the lim of the denominator, which will be lim. What's the denominator? We have 1 plus y. That is the denominator, right? Let's look at the right hand side there. If you notice too that whenever you differentiate the denominator here, it's give you the numerator here. So whenever you differentiate sine x, it is constant that whenever you differentiate sine x, it will surely give you cos x. So this is constant. So whenever I differentiate this denominator, it gives me what? Numerator. What did I do? What will you do here? You also take the ln of the what? The denominator, which will be ln. What is the denominator? Sine x. Mind you, whenever you are integrating, you must include your what? Your constant. I hope you understood. Whenever you notice that, whenever you are integrating, and you notice that if you differentiate the denominator, it will give you the numerator, right? Just take the ln of the denominator. If you differentiate the denominator and it will give you numerator, take the ln of the what? The denominator. So this is our final answer. See you in my next video on first order differential equation, and there are many other videos as regards this particular area. Stay tuned. Thank you.